Assalamualaikum warahmatullahi wabarakatuh. My name is Shazaf Multisim. I'm from J4EE 114B1. Today I want to present about assignment ELE242 about for question 1. Figure Q1 shows a subtractor circuit. Assuming the op-amp is ideal, determine the output voltage V0. Okay, V0 is here. Okay, then after that we apply VDR in here. 1K divided by 1K plus 2K multiplied with 9 volt. Okay, why 1K in here? Because it is connected to ground. So after that, after we calculate, we get 3 volts. Okay, we know that V plus equal to V minus. So it is equal to 3 volt. It means that in here, we get 3 volt. Here also, we get 3 volt. Okay, to know the value of V0, we need to apply current in equal to current out. Okay, I label this as I1 and I2 here because current in equal to current out. Okay, so for I1, 10 minus 3 divided by 1K, then 3 minus V0 divided by 1K. After we calculate it, we get that V0 is equal to negative 4 volt. Okay, how can I prove that my answer is correct? I will try at simulation later. Set out all the necessary components for this question 1. In addition, I have also changed all the components values to the same as the question. Other than that, I have also arranged the components in response to the questions in order to make it easier for me to create and to reduce the time it takes. Okay, first, same as question, I will construct it. Okay, then negative, it will connect it to 1K, which is the R1, and then positive, it will connect it to R2. Okay, next R4, it connected to at positive and also at R2 between. Okay, like this. Don't forget to put ground here. R4, it need to connect it to ground. Okay, then R3, connect it here, and then like this. Okay, I want to make V3. Then we use multimeter to know the value of V0. Positive connect to here, and then negative connect to ground. Then after that, after we done construct it, we can run. Okay. Okay, for question 2, figure Q2 shows a combination of two operational amplifier circuit. Determine the output voltage of V01 and V02. Assume all op-amps are ideal. Okay, first, if we get question like we have two op-amps, so it is easier if we consider one by one. Okay, so I consider A1 first. In here, I apply VDR, which is V plus K, 18K divided by 18K plus 30K multiply with 3 volts. Then I get 1.125 volts. So we know that V plus is equal to V minus, right? So it is equal to 1.125 volt. At this node, we get 1.125 volt. Okay. After that, I apply current in equal to current out to know the value of V01. Okay. So I1 equal to I2, right? Here is I2, okay? So I1 5 minus 1.125 volt divided by 120k, and then 1.125 minus V01 divided by 300k. Okay, after that we get V01 is equal to negative 8.563 volts. Okay, after we get that V01 value, we consider A2. When consider A2, I also apply current in equal to current out, which is here is I3 and here is I4. Okay, then I3 V01 8.563 minus V plus here divided by 20k, and then V plus minus 0.7 divided by 15k. Then after we get this equation, for me it is easier if we break the equation. It means that if we have V plus, we gather it right, and then for the one who had only the value, we gather it to the left. Okay, then after we calculate it, we get V plus is equal to negative 3.27. It means that V plus equal to V minus equal to negative 3.27 volts. Okay. Here is the value of negative 3.27 volt. Okay. Here also. Okay, after that we want to know the value of V02, right? So I apply current in equal to current out to. Okay, so it means that 0. Why 0? Because it is connected to ground. So 0 minus negative 3.2 volt divided by 27k. Then negative 3.27 volt minus V02 divided by 56k. Okay. For the value of V02, it is equal to negative 10.05 volts. Next, I will prove my answer in the simulation. Okay, for question 2, same as before, I have already laid out all the necessary components. I also changed the value of the components, and also I also arranged it because it is easier for me to create, and also for reduce the time it takes for construct. Okay, I will construct it. R1 connected to 5 volts, and then R2 is connected to 3 volts. Then for positive it connected to R1, for negative it connected to R2. For R4 it is connected at R2, then connected to ground. Don't forget about this, okay? So for R3 it is connected to R1, and then it is connected to V01. Okay, wait. Okay, R5 we connected to V01, then it will be connected to positive of op-amp 2. Next, R6 connected to positive sides. Okay, don't forget this alert about this 0.7 volt. Okay, and then same as before, same as R4, it is connected to ground. Then for know the value of V01, we need to use multimeter, so I will connect it to here, and then negative we connect it to ground. Then R7 as the question, it is connected to ground, and then it's connected to R8. Then R8 is connected to V node 2. Okay, don't forget about this, okay? Negative side, it's connected in between R7 and R8. Okay, after that, we can connect it to multimeter to know the value of V node 2. Okay, then after complete all the circuits, same as the question, we can run. For question 3, figure Q3 shows an instrumentation amplifier circuit. Calculate the output voltage V node. Assume all op-amps are ideal. Okay, same as question 2, I consider one by one op-amp first. So, I consider A1 first. At the question, state that V plus is equal to 10 volt. Then we know that V plus is equal to V minus, right? So, here too, it is also 10 volts. Okay, then for know the value of V node 1, I apply current in equal to current out, which means I1 is equal to I2. Okay, so V node 1 minus 10 volt divided by 1.5k equal to 10 volt minus 5 volts is equal to 1.2k. Why 5 volt in here? Because here V plus is equal to 5 volt, right? So V plus is equal to V minus equal to 5 volt. So here it is 5 volt. Then we get the value of V node 1, which is 16.25 volts. Next, I2, 10 minus 5 divided by 1.2k equal to I3, 5 minus V node 2 divided by 1.5k. Then we get that V node 2 is equal to negative 1.25 volts. After that, we need to consider A3 to know the value of V node. When consider A3, we need to apply VDR at here first. Why? Because we want to know the value of V plus and V minus for A3. So, I apply VDR 1.5k divided by 1k plus 1.5k multiply with V node. Okay, V node 2. V node 2 is equal to negative 1.25 volt. Okay, same as other question. Why 1.5k? Because it is connected to ground. Okay, the value is negative 0.75 volts. Okay, we know that V plus is equal to V minus, right? So it is equal to negative 0.75 volts. Then we need to apply current in equal to current out in here. So V node 1 minus 0.75, V node 1 here is 16.25 minus, okay, don't forget the negative, okay, negative 0.75 divided by 18k. Then I5 negative 0.75 minus V node divided by 18k. So we get that V node is negative 17.75 volts. Okay, later I will prove my answer with the simulation.
Okay, for question 3, same as before, I have already laid out all the necessary components. Also, I changed all the component values, same as the question. Other than that, I also arranged the component response to the questions. Okay, first, for the V plus, it is connected to V1, which is 10 volt. Then, for the V plus of op-amp 2, it will be connected to 5 volt of. It will be connected to 5 volt. Okay, then it will be connected to ground. Okay, this is also will be connected to ground. Okay, then for the V node 1, it will be connected to R1, and then R1 connected to R2, and then R2 will be connected to R3, and then V node 2 will be connected to R3. Okay, then R5 will be connected to V node 2, R5 will be connected to R7, and R7 will be connected to ground. Okay, then for the upper part, R4 will be connected to V node 1, then R6 will be connected to R4, and then R6 will be connected to V node 3. Okay, next, for the V minus of op-amp 3, it will be connected between R4 and R6. Meanwhile, the V plus of the op-amp 3 will be connected between R5 and also R7. Not to forget here, for the V minus of op-amp 1, it will be connected between R1 and R2. Then V minus for op-amp 2 will be connected between R2 and also R3. Okay, then to know the value for each of the V nodes, okay, for multimeter 1 will be connected to V node 1, positive will be connected to V node 1, and then the negative will be connected to ground. Then for V node 2, multimeter 2 will be connected to V node 2, while meanwhile the negative will be connected to ground. Same as before, V node 3, multimeter 3 will be connected to V node 3, and then the ground part, the negative part will be connected to ground. Okay, then after that we can run.
Last question 4. Calculate the output voltage of V node 1, V node 2 and V node 3 for the circuit shown in figure Q4. Assume all operational amplifiers are ideal. Okay, same as before, we need to consider one by one. In this question, we know that it's a little tricky, right? We need to observe it first. Then we get that V minus is equal to 0 volt. So we get that V minus is equal to V plus is equal to 0 volt in here, okay? Then we apply current in equal to current out. I apply this I1, current in I1 plus I2 equal to current out, which is I3. So 4 minus 0 divide by 2k, then plus 2 minus 0 divided by 2k equal to I3. I3 0 minus V node 1 divided by 1.5k. Then I will get that V node 1 is equal to negative 4.5 volts. Okay. Then we consider A2. Okay, we need to observe it too. Then we see that at negative side it is connected to 2 volt. So it means that V minus is equal to 2 volt, right? So V minus is equal to V plus. It is equal to 2 volt. Here we know that V node 2 is equal to 2 volts. Okay. Then after that, lastly we consider A3. A3, we can see that same as when we consider A1, we see that at positive side is connected to ground, which means that V plus is equal to 0 volt. We know that V plus is equal to V minus 2, right? And I apply current in equal to current out in here to know the value of V node 3. So current in I4 plus I5 equal to current out. I6 is the current out. Okay, then I4 V node 1 minus 0 divided by 1k plus I5 V node 2 minus 0 divided by 2.4K equal to current out, which is I6. 0 minus V03 divided by 2K. After that, we get the value that V03 is equal to 7.33 volts. Okay, that's it. I will also prove my answer by using simulation. Okay, for question 4, I already arranged the components and also changed the value of the components based on the question. I also added all the necessary components for question 4. Okay, so V2 is connected to the ground. V1 also connected to the ground. And then R1 will be connected to V2. R2 will be connected to V1. Okay, then V plus of op-amp 1 will be connected to R1. R2 will also be connected to V plus of op-amp 1. Okay, then V minus will be connected to ground. Okay, then R3 will be connected to here. Okay. Oh, sorry. Wait. Okay, like this. Okay, then R3 here will be connected to V0 1. Okay. Then for V minus of op-amp 2 will be connected to V1. It means that it will be the value will be 2 volts, right? So V plus will be connected like this. Okay. After that, R6 will be connected in here at V0 2, and then R6 will be connected to R4. V minus of op-amp 3 will also connect in here, and then R5 also will be connect in here. Okay, for R4 it will be connect in here. Okay. Okay, after that R5 will be connected to V0 3. Okay, after that sorry here don't forget pause this. Okay, wait. Okay, then to know value of V0 1, V0 2 and V0 3, we need to connect it to the multimeter. So positive will be connected here, positive of V0 2 will be connected in here. Oh my god. Okay, sorry. Then okay. Negative will be connected to ground. Okay, this is for value of V0 3. Then negative also will be connected to ground. Okay, then we can run. That's all from me. Thank you for watching and thank you for listening.